This is chapter 10 for statistics. We are doing correlation and regression, 10.1 and 10.2. This is question 3. Concern about global warming have led to studies of the relationship between global temperature and the concentration of carbon dioxide, CO2. Listed below are the concentration in parts per million of CO2 and temperature in Celsius for different years. Find the best predicted temperature for a recent year in which the concentration in parts per million of CO2 is 37.9. Is the predicted temperature close to the actual temperature of 14.5 degrees Celsius? So this question is given us data. So they give us a CO2 data and they also given us a temperature data. So these questions want us to construct the scatter plot and find the linear correlation coefficient R. They also want you to find the p-value. They also want you to figure out if there's a linear correlations. If I use the alpha as 0.05, and then find the equation of regression line. Again, your first variable is your x. So in this case, by looking at your data or your table here, so your x in this case will be CO2. So that's your first variable. And that means your y in this case will be your temperature. Again, very important to know this. If you do this, you will get it all wrong. If you switch these two around. And then E, find the best predicted value, means should we plug in the x. Your plug-in x in this case is 370.9. So this question wants us to figure out what is the predicted value when the CO2 is 370.9. And then there is a question. This question is asking, is this temperature close to 14.5 degrees Celsius? So the first thing we need to do is you have to type x equals to c for all the CO2 numbers, which is in your R, and y equals to c all the temperature in your R. So we just did this. So we begin to draw your scatter plot. So in order for you to draw your scatter plot, it should be plot XY. So this is an error message that you will receive. So if you have received this error message saying that your x and your y lengths differ, what is this x and y length differ? It means that you did not enter your data correctly. Or another word is there should be 2, 4, 6, 8, 10 data on your x, and if you count the y, there is only 9 of them. So actually you miss one of the variable number here. So yeah, I purposely do that so you guys know what's going on with this case. Your x is correct, but your y, I forgot to put in the last number, 14.4. So so when you do the plot xy, so this is the plot you will get. Okay, so I'm just want to point out to you that if you get an error saying that the x and y in this case is have a length that's differ, it means that your data that you enter is not correct. So you need to double check it. So if you look at this scatter plot again, you can copy and paste it to your work here. But the main part of this is this show linearity. Again, does this show curvy? No, this actually shows a linearity. It doesn't show a non-linear like a parabola or exponential graph here. So that's why it shows linearity in this case. Just want to point out to you guys here. Okay. So in this case, you need to find what we call as your correlation coefficient. So you do your summary LM y tilted x. There you go. Summary LM y tilted x. This is the one that we have. So this is the results you get. So your R in this case is this, but you have to take a square root of it. So square root of 0.7956. That will give us 0.89. So your R in this case is 0.892. And do not forget that to check your slope here. So like last example here, our slope here is negative. So my R is wrong here. It's supposed to be a negative 0.0079 because your slope is negative here. So for this question 3 here, my slope is positive. So that means your R should be a positive in this case. So this is pretty strong positive linear correlation in this case. Question B is asking us to find the p-value. So the p-value in this case is going to be 0.005219, which is either the last number here or the one that is right above here on the X here, okay, for the p-value. So these are your p-value in this case. Question C is asking us that to figure out there is a linear correlation or not using alpha is 0.05. So again, to write this, rho in this case equals to 0. This is rho, not p. That's your null hypothesis. Your alternative hypothesis is rho is not equal to 0. So we always do equal and not equals to for this case. Your p-value in this case is found in part B, which is 0.005219, which is less than your alpha, which is 0.05. So we will reject your null hypothesis. Since we reject your null hypothesis or your p-value is less than alpha, you can conclude that there is a linear correlation. So in this case, you can conclude that there is a sufficient evidence to conclude that there is a linear correlation in this case between what are the two variables we have? CO2 and temperature. Okay, so this is pretty good. So that means this is a linear correlation in this case. Again, class, when you do this, ABC is for section 10.1. DEF in this case will be for section 10.2 regression line. So next we need to find the regression line. Again, the regression line is based on your intercept and your x. Again, this is your y-intercept, this is your slope. So this is the same thing as what you learned in algebra, y equals to mx plus b. But we do not use y in this case, we use yx. So in this case, your slope in this case is 0.011x plus b in this case is 10.483. Or you can write this as 10.483 plus 0.11011x. So either one of this way, I'm accepting your answer, but make sure that you have a y hat next to it. Okay. Question E, to find the best predicted value, you have to fulfill the 3 requirements. So the first requirement you have to fulfill in this case is scatterplot. So your scatterplot shows linearity, which in this case is true, or yes, is good. The reason why scatterplot shows linearity in this case is because this scatterplot doesn't have a parabola or a nonlinear case here, so it does shows linearity. The second one is telling us that you have to figure out that there is a linear correlation. This is also true. This is actually comes from part C. In part C, we did testing, and it did show that there is the evidence to conclude there's a linear correlation. So that's why this is true. For the part 3, you want to figure out there is no extrapolation. So how do we figure out there's no extrapolation? Is you take 2 times mean x. So in this case, you just use your r. 2 times mean x. That is 67.5.4. So that means that your prediction here, your prediction value in this case, should be between 0 and 67.4. And based on what we have here, our x, if you remember what you need to substitute here, your CO2 is 370.9, so your x in this case is 370.9. So in this case, which is inside this range here. So no extrapolation here. So for this case, that since this is how we figure out is we take 2 times the mean, and then the 0 come from because the smallest one is 0, or you can because if you take 2 times the negative of mean, it's going to be from 0 to that number. So so we find out that this is 37.9. So it's inside the range, so there is no extrapolation in this case. Okay, that means this is true. So so you find out that all 3 of these requirements have met. So this is actually a good model, And if it's a good model, then your answer is you plug it into your y-head. So it's 10.483 plus 0.011, and your x in this case is 370.9. So in this case, since this is a good model, we can plug it into your regression equation here. 10.483 plus 0.011 times 370.9. So that is 14.56 degrees Celsius. Okay, so this is how we figure out how do we do the best predicted value. So you have to go through these 3 requirements. Yes, someone asked me, do you want to put this in your test? Do you want points? So this costs you 3 points here. If you did not do this 3 requirement test and you just simply plug into this model, you automatically lose 3 points here. Okay, so next question is answer the question. So this question is asking, is the predicted temperature close to 14.5, which is the actual one? You find out that 14.5 and 14.656, they are very close. Then the answer is yes. The predicted value and the actual value is close. Now, if you still remember what we did, how last time, if you got something that is like, you don't know that close, because this is very obvious, 14.56 and 14.5, they are very close. What happens if you figure out, how do you figure out if this is really close or not? So we did this back in chapter 3 is you have to find the percent difference. So how do you find the percent difference is the amount difference over by the actual amount, then times 100. Times 100. Okay, so so you have to multiply by 100. So in this case, if you want to figure out and this percent difference has to be less than or equal to 5%, then your answer in this case will be yes, they are close. Otherwise, if it's more than 5%, then your answer is no, they are not close. Okay. So, so this is how we figure out the percent difference here. So the amount difference means you take the amount that you have for the predicted one, which is 14.56, and then you minus the actual amount. The actual amount in this case is given us by 14.5. And then you divide this by 14.5, which is the actual amount, and then you multiply this by 100%. So, so if you use your R here, so you take 14.56 minus 14.5, put parentheses around it, make sure you have that. And then you take this divided by 14.5, and then you multiply this by 100%. This came out to be 0.414%, which in this case is less than 5%. So that's why your answer in this case is yes, they are close. Okay. So, so this is another way for you to figure out for part F to answer yes or no, is you do have to find the percent difference. If it's less than or equal to 5%, then your answer is yes, otherwise it's no. And this is how you find your percent difference for this example.